Proximity measures. This is a nice topic. Actually, from this, if you are doing FYP, you can try to find some contribution by using proximity measures. Okay, maybe later you can try to figure out how you can have something where you can apply proximity measures inside your FYP, maybe as part of your contribution. Okay, so proximity measures is another definition for similarity and dissimilarity measurements. So now we are going to discuss how to measure two objects, how similar they are or how different they are. Let's say I have two records about cars inside my data set, and I wish to see how similar these cars are. So I need to know what type of measurement I can apply in order to measure how similar or how different they are. Okay, so proximity is about measuring the similarity or dissimilarity, or in other words, sometimes instead of saying dissimilarity, we say distance. Okay, so similarity and distance, or similarity and dissimilarity, same thing. Okay. So the idea is, let's say I got objects and I would like to measure them to see how similar they are or how different they are. Like, if you remember, one task of data mining is clustering. Remember, we mentioned in the introduction slides where we mentioned about the tasks. So clustering, how they gonna group, let's say, a list of objects. If I provide data set with a list of objects, how they gonna group them up? So grouping means if I put set of objects in one cluster, that infer that these objects are similar, right? And if I put other objects, that means they are similar in the other object, but they are different from each other as an object from one cluster against another cluster. So the point is, for example, when we do grouping, I need a way to find out how I can group these objects together into two groups, two clusters. So I need similarity or proximity measures in order to measure how similar they are. So those objects that look very similar in the proximity or similarity measurement, then I can put them into one group. And those other objects that are more similar to be in different group, then I put them together and so on. Okay, so proximity measures are mathematical metrics used to determine the similarity or distance, as I said, between two data points or objects in a feature space. These metrics are used in a variety of machine learning algorithms to quantify, to measure the similarity or dissimilarity between data points. Okay. Now, proximity measures can be classified into. So we have some measurement that we're going to discuss about soon. They're helpful to measure the distance or the dissimilarity, while some measurements are helpful to measure how similar they are. Okay. So if you like to measure how similar they are, there are certain measurements. If you like to measure how different they are, then there are other measurements to apply. Okay, so distance measure quantify the dissimilarity between data points, while similarity measures quantify the degree of similarity between data points. Distance measures are commonly used in clustering. Like just now I mentioned an example where we like to use clustering. So usually distance measures are used there, such as k-means. We're going to talk about k-mean algorithm when we move to the topic of clustering, and hierarchical clustering, as well as in classification algorithms such as k-nearest neighbor. Also, we're going to talk about k-nearest neighbor as one of the algorithm applied for classification. So k-means for clustering, k-nearest neighbor for classification. Similarity measures are often used in recommendation systems. This is why I'm telling you, if you like to apply some sort of recommendation inside your system, like let's say you are building event management system, right? So event management system is not machine learning, but if you wish to have some element of recommendation, like let's say this person has registered for these events, then you can like have something, a tip for him saying, those people who have registered in these events commonly or usually also maybe registered in these events as well. You are giving him some recommendation. So if you wish to have that as contribution, this actually can be a good contribution for you. And you see these can be applied even for non-machine learning projects, okay? Like you have event management system, then you like to recommend to the user similar events, maybe in their content, maybe these events, you try to have data set describing these events, whether they are scientific, I don't know, physics, and so on and so forth. Then you try to find which events are similar in overall content. Of course, I'm not talking about one category. So you may think, oh, what he's talking about. I mean, I have events are, let's say, about, for example, machine learning events running inside the organization. Then, of course, all the events that have been tagged as machine learning, I can recommend them. I'm not talking about this. I'm talking about the content of these events in more complicated way. Maybe they are machine learning, maybe they involve some physics, for example, they involve some mathematics, they involve what? What is the content inside? Then I can, let's say, have 8 to 9 topics involved in each event. Then I would like to see which one is most similar. Now it's not easy, right? If you have just single tag, single category is easy. No need actually to apply recommendation. Straight away, I mean, you don't need to apply proximity measures. Straight away, you can recommend all events that belong to the same category. But let's say you have categorized your events into different categories. Let's say machine learning, maybe talking about nature and nature space, and so on and so forth. So you have many content describing this event. So you can apply proximity measure to see which other events are also most similar to this event, and then you can recommend to the user. Or you can also measure, see how similar, let's say, the events I have attended as a person, as me, with other people. So they're gonna see how similar I am to other people in terms of the events or the content that I have attended. Then let's say me and your friend have attended most similar. We are most similar to each other. Then the system can see what other events he has attended that I have not attended yet. Then the system can recommend to me as well. Okay, so there are different cases, but the point is this is simple topic, kind of simple, and actually you can use it as contribution for your FYP, even if you are doing non-machine learning project. Okay, so now all of you have some idea for contribution. We're gonna see later as you go through the topic, then you can figure out how you're gonna apply it in your project. Okay, so again, proximity measures, we have two categories, similarity measures and dissimilarity. Okay, for similarity measures, numerical measures of how alike. So here we are looking how similar two objects are. While here we are looking how different, how dislike two objects are. The similarity measure. Here, similarity measure, the higher the value, let's say you calculated similarity measure, the value, the higher when objects are more alike. Okay, so let's say if I measure two objects, let's say between your friend and me, I apply similarity measurement, and then similarity measurement says 0.9. That means it's high value. If it's 0.1, low value. Okay, so the higher when objects are more alike. Often the range for the value of similarity falls between 0 and 1. Of course, it doesn't mean only 0 or 1. That means in between. There's a range, maybe 0.1, 0.2, 0.3, and so on. 0 mean there's zero similarity, no similarity at all. If I calculated similarity measurement, 1 means completely similar. This similarity lower when objects are more alike. In other words, if you like to put it in the same term, is higher when objects are more dislike. Objects are more different. Okay, so I think it's better if you put it in the same term, but this is correct, this is correct. Okay, so higher when the objects are more dislike. In other words, lower when the objects are alike. Minimum dissimilarity is often 0. Upper limits vary, right? So here between 0 and 1, but here it can vary. 0 if you calculated the similarity object measurement, and then the 0 value means objects are completely alike, correct? dislike. So you can say this is are alike, or you can say they are completely different. In other words, 0. Correct? Here, it depends on the value. As you go higher, the objects are different. Sorry, here if it's 0, that means there's 0 dissimilarity between them. That means objects are alike. And as you go higher, then the distance increases. That means there are more differences between them. Actually, it's not confusing, but just because different wording used for each category, it may look like this, but same way. Okay, so now again back to the data types. You see how data types are important? So now we mentioned mapping, we mentioned replacement. Also in the proximity measures can be different. How you measure differences or similarities between them, between those features. So if you are talking about nominal, so quite easy, because nominal only we can use distinctness. Equal, right? So if we're talking about similarity, equal is going to be 1. If two objects are equal, that means they have one similarity. 0 means dissimilarity. If they are alike, right? That means they have 0 differences. If they are not same in similarity measurement, it's going to be 0. In dissimilarity or distance, is going to be 1. If you are talking about ordinal, so you see now, D here, D stands for distance or dissimilarity. S stands for similarity, if you like to know. So here, if we have ordinal, then we cannot apply like this. We need to go a bit more complicated. Then we need to extract the values from, let's say, object 1, object 2, and then divide it by the number of options we have. Now we're going to have an example soon. Now, if you calculated dissimilarity, you can convert also between dissimilarity and similarity. So here, if I have calculated D, I can just substitute here to get S. If it's interval or ratio, just you can calculate it dissimilarity like this. You cannot do division here. I mean, for the calculation of dissimilarity. For similarity, there are many options you can apply to calculate similarity based on dissimilarity. So you have D. You can just simply say S equal minus D based on the D you have calculated and so on. Let's see an example. Here we have, let's say, ordinal attribute. We have performance, where performance can take values poor, fair, okay, good, wonderful. So this is ordinal feature. Why? Because it's categorical first, right? We have categories, plus it preserves the nature of order, right? So we know that, let's say, wonderful is the best, followed by good, followed by okay, followed by fair, and the worst one is poor. So the nature of order, the ranking is there. So this is ordinal, right? Okay, I can answer, right. If you think it's not right, then tell me not right. Then we can have fighting discussion, of course. Okay, now let's say you wish you have to, let's say these are the performance for the student. This is student ID 1. You check the performance column, he got poor. Let's say student ID 2 got the performance is good. And you wish to measure how distance between S1 and S2, between student 1 and student 2. So since this is ordinal, right? Again, if you like to fight, tell me, we can fight. So we check ordinal. Ordinal says you need to take the distance, the difference between two values divided by the total number of values minus 1. Let's see. Firstly, ordinal, that means I need to do mapping. Just now I discussed, we need to do mapping. So I have assigned values for these 5 categories. So value poor is going to be given value 1. Value fair is going to be given value 2. Okay, 3, good 4, wonderful 5. If nominal, again, just I'm trying to make revision all the time for you. If nominal, you cannot assign 1, 2, 3, 4, 5. Either 0 or 1. Later, we can discuss how we can deal with it. But anyway, the case here is for ordinal. Now we come here. Then what is the distance between the performance of student 1 and student 2? Now, student 1 has got the value poor. According to the mapping I have provided, poor equals 1. All right, so I put 1. How about the student 2? Student 2 performance is good. according to the scale I have provided, good means 4. So 1 minus 4 equals 3. If you like to stop here, also can. But if you want to have the similarity fall between 0 and 1, then it's not over yet. So this is why here what it says, okay, wherein we need to divide this value. So we map between some value and n minus 1, but we need to, here in this case, to convert between 0 and 1, then we need to find n minus 1. N minus 1, easy. N means the number of options you have. So for performance, how many options I have? Either poor, fair, okay, good, wonderful, means 5. Then 5 minus 1 is 4. Then 1 minus 4 with absolute value, because here you're going to get negative, divided by 4 is going to be 0.75. That means they are different, these students, 75% in terms of performance. In performance, these two students are different 75%. Right? It makes sense. How about if the student 2, or let's say if we take student 1 and 4. If we take student 1 and 4, then here the value is going to be 5. So 5 minus 1 is going to be 4. 4 divided by 4 means 1. These two students completely different. One got the worst mark, one got the highest mark. Okay? Clear? You understand what does it mean, 0 and 1, and how it makes sense? Okay? So this is an example showing you how you calculate this similarity or the distance. Now, if you wish to see how similar these students are, then you can refer back to the table. So in case of ordinal, very simple. Just you subtract the value you have got from distance from 1. So the value distance must be subtracted from 1. So in this case, 1 minus d. In our case here, 1 minus d, that means 1 minus 0.75 equals 0.25. That means these students are similar only 25%. All right? And again, if I'm measuring student 1 with the student 4, so distance is going to be 1. Here, distance is going to be 1. Then 1 minus 1, 0. That means they are also 0 similar. There is no similarity at all. One got, again, the lowest mark. The other student got the highest mark. Good? Okay, now we move on. Okay, so now this is just an example showing you in case of ordinal. Now let's go and discover what measurements we have. Let's start with the first one. First rule, which called Manhattan distance, or you can call it also taxi cab or city block or L1 norm, all same, referring to the same measurement, but just with different names, different titles. For Manhattan distance, actually is quite easy. It is just the sum of absolute differences. Let's say I got these two objects. I have object A, object B. And these two features value. Let's say feature 1 got the value 2, feature 2 got the value 9. And then for object 2, I got the feature 1 value 3, object 2, feature 2 value 5. And I wish to calculate the distance using Manhattan. So Manhattan simply just you take the subtract, you subtract between the values while taking the absolute. So in this case, we start with A1 minus B1. That means I take the first value from A minus the first value of B, right? Because this is represent here one feature, the value of one feature. Yeah, here I cannot use marking because I'm using MS Team Web. Okay, if I like to fix my hand, so this is column 1, feature 1. So now just I subtract A1 minus B1 plus absolute, of course, plus value 2 from object 1 minus value 2 of object 2. Then I substitute n minus 3, absolute plus absolute, 9 minus 5 equal 1 plus 4 equal 5. So the distance between A and B is the value 5. Okay? So this is by using Manhattan, or we call it taxi cab. If you like to apply using Python, then there's a library called SciPy, SCIPY. They have a module called Spatial. You can import a function, or actually this is also should be another submodule called distance. Inside distance, you have a function called city block. City block. City block. So this is about Manhattan. You give object 1, comma, object 2. Student 1, comma, student 2. Car 1, comma, car 2. So you are calculating the difference, the distance between two objects, and you can report about Manhattan distance. Okay? Second one, I think most of you are aware of, Euclidean distance. Anyone doesn't know Euclidean? I think this is since high school. I remember we took this even in high school. This is one of the famous measurements where you calculate the distance, called Euclidean. So Euclidean, simply what do you do? You take the subtraction to the power of 2. You take the summation for all, let's say, the distance, the differences of features. Finally, you take the square root. Okay? So here an example. Let's say I have list of data points or objects or student, and then I have feature X, feature Y, and I would like to calculate the distance between them, between these data points. Then I can calculate using Euclidean. If I opt to go with Euclidean distance, then, for example, if you apply between calculating the distance between the point and itself, of course, must be 0. There is no distance between P2 and P2 itself, or P3, P3. Then you calculate the distance between P1, P2 using Euclidean, P1, P3, P1, P4. So here is an example if you wish to do calculation on your own, the answer here. Straight away, just to substitute in the Euclidean distance equation. Okay. Next one is Minkowski. Minkowski distance is also another measurement for differences called Minkowski. Minkowski is generalization of Euclidean distance, because if you check the equation is kind of similar to Euclidean, right? So here we have the distance, the difference, and then to the power of r. In Euclidean distance, r simply is the value 2, right? The value 2 is simply r value. You can substitute here for Minkowski. And then SQR square root in Euclidean distance, how we can represent it mathematically? Mathematically, square root, if I need to put to the power all this, instead I remove square root and I use square bracket to the power. What value of power represents square root? Okay, good. 1 divided by 2, that means 0.5. Okay, 0.5. So if you like to try on your machine, your calculator, if you have to the power, then try value, calculate the square root, or to the power of 0.5, you should get same result. Either the power 0.5 or you calculate the square root, same value, same result. So this is why Minkowski distance is a generalization of Euclidean, where r should be equal to. So if r equals 2, then it's Euclidean. Because we substitute here, this becomes to the power of 2. And then 1 divided by 2 means 0.5, which represents square root. So it becomes Euclidean distance. But if r equals 1, what would happen if r equals 1? Firstly, here, nothing happened because the power of 1, 1, right? Here, 1 divided by 1, still 1. Then becomes, looks like what? It becomes Manhattan, city block. Okay, so Minkowski is generalization, measurement. So based on the value of r, if r equals 1, actually it becomes Manhattan. If r equals 2, becomes Euclidean. Okay, and so on. So here it's already mentioned, r1, city block becomes. If r2 becomes Euclidean, okay, then if you put some value, high value for r, then also can, let's say you take 50, okay, then this is the maximum difference between any component of the vector. Here is an example, same example earlier, okay? Then here shows you this, the first table, the result of L1. L1 means Manhattan. Just now we mentioned earlier, L1 is Manhattan. L2 is Euclidean. L infinity, then we're talking about Minkowski. So here we have L1 table. This is for Manhattan. If you like to try on your own, you should get this result. This is L2 for Euclidean distance. L infinity, this is for Minkowski. In order to get these values, substitute R with high value, like 50. Then you should get these results. Okay? Okay. Second distance, so we talked about Manhattan, Euclidean, Minkowski. We have Mahalanobis. Mahalanobis. A bit difficult, but you can practice. Say Mahalanobis 10 times. It should be easy. Mahalanobis also is one of the statistical measurement and also is considered generalization of Euclidean distance. Okay, considering the covariance of data, which provides a more accurate distance measure in case of data are correlated. In other words, this is the equation for Mahalanobis. Mahalanobis takes into account that, let's say if you are calculating Mahalanobis for X and Y, two objects, object A, object B, like earlier. Mahalanobis is good when there's a correlation. Sorry, not object 1, object 2. Let's say between feature X, feature Y. If there is a correlation between them, that means one value is going to be, you're going to see, let's say, one feature. As you increase the value, the second feature also, the values are going to be increased. Okay? Like, for example, if I suspect two students have cheating case, then when the first student does bad, the second student is going to do bad as well. If the first student does good, then the second student is going to do good as well. That means their marks are correlated. There's correlation between their marks. Okay? Clear? Now, Euclidean distance assume in its assumption there is no correlation when we are calculating the differences. Okay? Assumes that there is no correlation. But Mahalanobis takes into account that you might have correlation between these two features. So Mahalanobis is good when you suspect that there's correlation between your features. So you can apply Mahalanobis. Okay? If there is no correlation, then when you substitute here, the covariance matrix is going to actually has no impact. And then actually you're going to, at the end, get like similar to Euclidean distance. Okay? So here, this is an example, nice one, showing you. Let's say I have two objects here, and I have feature X and feature Y, and I'm interested to calculate the distance, how far they are from each other. If I use Euclidean distance is going to give me 14.7, because considering there's no correlation between them. But if these two features have correlation, do they have correlation? Yes. Actually, if you look into this later when we also talk in visualization, what does this scatter plot? This is scatter plot, right? We have dots. What does this scatter plot shows us? That as you increase the value of X, value of Y increases as well. Take any data point. Let's say this is low 1. You have X here, right? If you check Y, Y is going to be here at this point. How about if I take this? Now X is high. When I inspect Y, Y is high as well. So there's correlation between X and Y. Okay? There's correlation between X and Y. If there's correlation, Mahalanobis is going to actually do better. So Mahalanobis is going to show me the right distance, which is 6, while Euclidean is going to show me 14.7. In case there is no correlation, Mahalanobis and Euclidean is going to have the same result, same answer. Okay? So this is another example. If you like, you can try on your own to substitute, and then you get it. If you like me, then later I can explain, but just you can go and substitute. This is the covariance matrix, okay, the sigma. You can substitute, and here are the data points, A, B, and C. And here for feature X, on x-axis, A has 0.5, B has 0, C has 1.1, 1.5. Feature 2, A has 0.5, B1, C 1.5. Then if you substitute, already given to you, for example, if I'm calculating the distance between A and B, Okay, then you can substitute inside the equation. You should get A and B, the distance is 5, A and C is 4. Okay, so these about differences. Any question? Okay, we still have 10 minutes. Actually, we're almost over. Which is good. Now we move into the similarity measurement. So now we are starting with similarity measurements. Okay. Similarity measurement, we start with simple matching coefficient. Simple matching coefficient. This is one of the similarity measurement, not distance. This shows you the output should be the similarity. Very easy. In order to calculate SMC, simple matching coefficient, you take the number of matches between, let's say, you're calculating the similarity between two objects, object 1, object 2, divided by the number of attributes. Okay, so the equation is going to be like this. Now we see an example, then you understand. Let's see the example, I think easier. Here. Let's say I got two objects, X and Y, okay? Or you can think of them A and B. And then these are the features. At each feature, I marked 1 or 0. 1 mean exist. Let's say this is about car 1, car 2. So let's say gear shift. The first car has gear shift, the second car doesn't have gear shift, which doesn't make sense. Let's say automatic gear shift. So the first car has 1, the second car has 0. Or if you remember, if I told you the example for event management, if you are working, of course, just I'm giving you an example. You can match it for any FYP title, similar thing. So if you like to do recommendation based on the content, right, then you can have 1 meaning, let's say the event has certain topic, while event 2 maybe does not. 0, 0 means they don't have. This topic is not related to X, neither Y, event Y, and so on and so forth. And you wish to calculate how similar these events are. Of course, now we should get 0. It's quite clear there is no similarity whatsoever because there is no 1-1 matches. Okay, in order to do this, we substitute, this is our equation. So it says F11 means you need to find how many matches of 1-1 between these two objects. Okay, so F11 means the number of attributes where F11, the number of attributes where X was 1 and Y was 1. Never. They never have matches of 1-1. So when we substitute F11, it's going to be 0 plus how many matches we had where they have matches 0, 0. Actually, there are quite many. This is 1, 2, 3, 4, 5, 6, 7. There are 7 matches of 0, 0. So we substitute, we get 0.7 plus 7 equals 7. And then similarly, you substitute with the others. Like F01, that means F01 where the number of attributes where X was 1 and Y was 0. So this is 1. There's only one case, 1, 0. Oh, sorry, 0, 1. 0, 1, we have 1, 2. So it's going to be 2. F1, 0, 1, so on and so forth, you get 0.7. That means they are similar 70%. Okay? Maybe someone will ask, how come we have 70% similarity? Anyone would like to ask or has this doubt? If nobody, then I can just skip. Anyone has maybe concern, how come these two objects are similar 70%? There seems no one, huh? So just I can skip. No need to explain. No need, nobody asked. Okay, just we skip. Sorry? Why? Okay, since your friend says why, then later you blame him, huh? Okay, now these objects, yeah, actually they might look not similar, right? Because there is no 1-1 matches. This is in your mind, you may think like this. But simple matching coefficient doesn't only look to 1-1 matches. It looks also to 0-0 matches. Just look to the equation, right? So this is why we got 70%. Okay, So in case you are working where you like to consider 0-0 matches as well, then you can take simple matching coefficient. But of course, if you are working like on FYP title, event management system, and you like to recommend, of course, you don't recommend based on 0-0 matches. Let's say event A doesn't talk about machine learning. Event B doesn't talk about machine learning, but you consider them similar in that sense. Maybe they are talking about something else. But because they are not similar in this aspect, they have matches 0-0, so you consider them similar. If you like to exclude 0 into the equation, you don't take 0-0 matches, then we have another measurement called Jaccard. Jaccard coefficient. Jaccard coefficient is same as simple matching. The only difference is equation. If you look here, Jaccard doesn't take into account 0-0. So if you calculate this time, again, similarity is going to be 0. There's 0 similarity between X and Y. Clear? Why earlier here we got matching 70% similarity? Because we consider 0-0 matches. It might be useful in certain cases. I'm not saying otherwise, simple matching coefficient is useless, we may think, but actually no, it may be useful in some cases. Okay? It depends on the case you are studying. So if 0-0 makes sense to you and your problem you are working on it, then you take simple matching coefficient. If 0-0 doesn't make sense to you, it's not considered valuable having matches of 0-0, then you go with Jaccard. Actually, just these two you can apply on any FYP project. You can have some recommendation. Let's say you are working on, as I said, event management system, then you can recommend events. Okay? So anything, maybe purchases, you can recommend other purchases based on how similar two transaction or two people are, or maybe movies. What first person, what type of movies he watch, X. Second person, what type of movies he watch, based on the content, horror, I don't know what else, adventurous, and so on and so forth. Then you prepare your vectors for two people, okay, and then see how similar they are. Okay, either by using simple matching coefficient or Jaccard. Then you apply for all other people inside your data set and see where pair of people are most similar. Okay, then you can recommend what the other person have seen to the first person. So actually it's quite simple, but just if you don't understand now, you can go back home, sit down, and put for each column of these one feature. Maybe if you're talking about movies, then this is the first match is about adventures, whether these two movies are adventurous or not, or horror or not, and so on and so forth. So last week we started with the proximity measures. Any question? And we have reached the last section, or last few sections. I remember we stopped here. All right, so we talked about what is proximity measures are used for. Okay, so we use proximity measures to measure the similarity and dissimilarity or distance between two objects, right? Two records to see how similar they are. So some algorithms are these types of measures can be useful for some algorithms, which we call them distance-based algorithm or instance-based, where they require to do calculation, like this type of calculation, where to calculate the similarity or dissimilarity. Okay, one of the famous algorithm that we're going to talk about later is KNN, K nearest neighbor. Requires, for example, you can use Euclidean distance along the way to find out how to classify when we talk about prediction in general. We're going to find out how KNN is going to use Euclidean distance, for instance, in order to find the predicted value. Okay, and for clustering as well. So we stopped here. I remember we already talked about SMC and Jaccard. So SMC was for one of the similarity measurement, stands for simple matching coefficient. And it's about calculating the number of matches between two objects. So if we have, for example, as given here, let's say we have two objects. So always link to it inside your minds that you have two objects, two records, okay, like X and Y, or record 1, record 2, record index 0, record index 1. Then we got a bunch of features. So here, how many features we have? Each column is one feature. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we took the corresponding value for this feature, and we would like to see how similar these two objects is, how similar they are, okay? So simply, just we calculate following the equation, then we found out using SMC that the similarity is 70%, because similarity is between 0 and 1. So when I say 0.7, that means similarity is 70%. When we say 0.8, that means similarity is 80%, and so on. So we found out that similarity is 70%. Why? Because simple matching coefficient take into account the matches of zeros, though they may make no sense, but this is how simple matching works, okay? But if you apply another measurement also for similarity called Jaccard, Jaccard is going to consider only one matches. The one matches. That means we must have one matches to consider as one. Okay, so if we come to the same example following Jaccard, then only in the nominator we have the matches of 1, 1. Then how many 1, 1 matches we have between these two objects? None. We don't have any 1, 1 match, any 1, 1. So in this case, according to Jaccard similarity, the value, how similar they are 0 similar. There is no similar whatsoever. Okay, clear? By the way, these two SMC and Jaccard are for binary representation only. That means my attribute, my features, has only to have value 0 and 1. Not 2, not 3, not 4, only 0 and 1. So 1 means, for example, probably exist. 0 mean no existence. Okay? Like you can think here if we have two events. So we put the features of the events. What characteristic or properties of events you have for each one. So this X is event 1, Y is event 2. And then I would like to see how similar they are. So this is why I told you if you are doing FYP, even normal traditional project which involves no AI, you can still apply these concepts, are very useful. Then you can find how similar two events are. Okay, based on how similar they are, let's say I have attended, this is my record, okay, for the feature of events that I have attended. Then you would like to find out for other events that are very similar to the event I have attended. Then you can recommend to me, right? For example, applying Jaccard, you would say, okay, event Y is no similar to event X, which I have attended earlier, so I don't need to recommend it. You don't need to recommend it to me. Maybe you look for other events, maybe event Z, event A, event B, okay? So you can keep looking for matching for other events. Cosine similarity is also another similarity measurement, but the difference is here, the values can be, not necessarily be binary. So the values can be 2, 3, 4, 5. For simple matching coefficient, and Jaccard values has to be in binary format, either 0 or 1. That's all. For cosine, no, it's okay. You can have 2, 3, 4, 5, and etc. Okay, this is the equation for cosine. It looks scary, but actually it's easy. We're gonna find there's an example, nice one. The point is, in order to find cosine, the cosine similarity between two objects, let's say object D1, object D2, or record 1 again, record 2, okay, inside your data set, you need to take the inner product, this represents the inner product, divided by the vector of magnitude, or the length of each object. We're going to find out how you calculate. Let's say we have two objects, X and Y, D1, D2, or index, record index 0, record index 1. And you would like to apply cosine similarity to see how similar these objects are. Okay? Like, for example, take the practical session we worked on. Right? We were talking on housing value. Then maybe you need to measure how two districts are similar. Maybe district at index 0 district at index 1, district at index 2. You would like to see how similar they are. Okay? So you can apply cosine similarity. So the point is, let's say, assume that these are the values for record D1, and these are the values corresponding to the attributes of D2. Inner product, very easy. You just multiply value to value, element-wise. Remember element-wise? Multiplication. So just you do element-wise multiplication. So 3 divided by 1, followed by 2 divided by 0, 0 divided by 0. Of course, you take the summation, element to element. Okay, but actually, no, this is not just element to element. This is here where you are actually doing multiplication because you need to take the summation. It's not just element to element. Okay, sorry, it's not just element to element. So you need to multiply element to element, yes, but you need to take the summation. After all, you should get a secular value, single value. So this is for denominator. For denominator, you need to calculate the vector magnitude. Vector magnitude, quite easy. Just you take each value and you take to the power of 2, and you keep summing up all the values. Finally, you take the square root. For example, let's take back this one, D1. In this case, we take 3 to the power of 2. 3 to the power of 2 can be represented meaning 3 multiplied by 3, right? You remember to the power, if I say 10 to the power of 10, that means I'm multiplying 10 times. So 3 to the power of 2, simply 3 by 3. Then 2 to the power of 2 is 2 by 2, and so on. Then I sum up, and I take the square root, which is simply the power 0.5. I get this value, 6.481. Then I redo the same thing for D2. Finally, I apply in this equation. I got everything. Just I substitute inside the equation. Then I get cosine similarity for these two objects, D1, D2, are 0.315. That means they have similarity 31%. They are 31% similar. Okay? So this is about cosine similarity. So I have put these records, maybe easier for you to understand, inside table format. So this is Hotel A, Hotel B, and these are the features we have based on the rating for each hotel we got earlier. This is our friend Khalid. He has rated other hotels. So he already have booked a hotel called X, and he already have stayed there, maybe overnight. Then he gave some rating. Based on his rating for the hotel that he has booked earlier, we would like to recommend him another hotel. Okay, nice. So you can, based on your FYP, you can build the story, something similar. So now how we can recommend, whether is it Hotel A, we should recommend to Khalid, or Hotel B. So we need to find out, we can apply cosine similarity. So we start with cosine similarity with record for Khalid, which is marked by X for X hotel, and along with Hotel A. So again, we go with inner product first. So 4 multiplied by 5 plus 2 multiplied by 3 plus 5 multiplied by 4, and so on and so forth, divided by the, what we call it, the vector magnified, or the length of the vector. So we take Khalid rating and Hotel A. Then we start 5 to the power of 2 plus 3 to the power of 3 plus a power of 2, then 4 to the power of 2, and so on. Then multiply by the rating for Hotel A. And then we do calculation. We find that the rating for Hotel X, Khalid has stayed at, and Hotel A is 97%. They are similar. And then we repeat the same step with Khalid record along with Hotel B. Then we find that the similarity is 98%. So based on this cosine calculation, we recommend Hotel B because Hotel B is more similar than Hotel A. Hotel A got 97%, while Hotel B 98%. Okay? Clear? So this is how recommendation works. For example, if you like to use cosine similarity, then you can recommend to the user maybe other events. It depends on your project that you are working on. Any question? Now we go to correlation. We already explained a lot about correlation, right? In just practical session, last few days, and some of you just today. So the information should be very fresh. It's the second time, you don't remember? Already forgot. Wow, very fast. You have RAM memory. You need ROM, R-O-M, so you can fix the information for longer. Okay, so what is correlation is about? Correlation is about finding relationship between two objects. So we'd like to find out how similar or what is the relationship between them, whether they are correlated or not. Like the example I've given you earlier during the practical session between number of years of experience and salary, right? So based on if we wish to find out whether there's a correlation or not, then we can apply correlation to find out. Based on correlation, there is a calculation you can apply. The value of correlation, as we said, should be between -1 and 1. Then it will actually tell us how these two objects are correlated to each other. So this is the scatter plot, scatter plots. So here, if you, this is maybe more familiar, remember here where the correlation is significant or perfect in this case, because it's equal to 1, the maximum value given. So here the correlation is at maximum. Here, maybe at 90, 0.9, here 0.8, until we reach an area. If you check the scatter plot like this one, 0, the only thing, like if you like to draw, is the line is going to be horizontal to the x-axis, meaning correlation is going to be 0. -1 is the opposite. So as we are moving on x-axis, as we are increasing the value on x-axis, the value on y-axis decreasing. So they are in opposite. They are correlated, but negatively. Okay, they are correlated, but negatively. But correlation has negative feedback. If you remember, we said earlier also during the practical session, correlation detect linear relationship, linear. So if you notice here, when we are drawing, we are looking for correlation line or regression line. It should be a straight line to represent these scatter points. Okay, how about this one? If we take this figure, so we notice that at some point as x increases, what happened to the y? Y is decreases. So if you take this point at -2, projected on x-axis, it's going to be -2. On y-axis is going to be 4. Then as we move forward, let's say at 0, x has increased, but y has decreased, correct? So we have negative correlation at this stage until here. After 0, things has started to change. X still increases, but this stage y, and instead of keep decreasing, start to increase. In this case, we call it non-linear. You see the line we got? This is non-linear line, or we call it curved line. If this is the case, like this one, correlation may fail to detect any relationship between these two variables. Okay, though there is a relationship, it's quite clear. If the value is less than 0, it's negative, right? Any changes on x, any increment on x, it's reflected on y with decrease. The value is going down. After x, things start to change. As we increase on x, value on y start to increase. So there is a relationship, but we call it non-linear relationship. This is why correlation will fail in this case to detect. This is one of the drawbacks of applying correlation. So if you apply correlation, it's not the final thing to say whether there is a relationship between two variables or not. Okay, like in this case, we have curved relationship, curved line, so correlation will fail. Okay, in this case. So how to detect relationship? Nobody asks. So let's say if someone asks how to detect in this case, you need to apply regression, non-linear regression. So we're going to discuss about it later. Regression also has two types, linear and non-linear regression. So for this case, we need to apply non-linear regression because linear regression will fail as well to detect the relationship. Okay? So later we discuss about regression. Let's have a good example to if I ask you to find out whether there's correlation between two features. So what we can do, like what we have done in the practical session, right? Well, how did we find out? We found out by calling correlation. So we did the calculation, right? Or we can do visualization, correct? We used scatter plot earlier in order to find out whether there is correlation between two variables or not. So if I ask you, I've given you this data set, this is sample of the data set. And then the question comes in, explore the relationship between age, income, and purchase amount column to identify any correlation or pattern within the data. Okay, so what you need to do, a simple way, what you could do in this case, if you like to apply lame way, simple way, what do you need to do? What do you need to do? No idea? Okay, let's see. The simple way one, first go and sort the values in ascending order based on one of the selected column. Then compare the sorted value in both columns. Let's say you are working to identify whether there's a relationship between income and purchase amount. So first go and sort the value in ascending order based on one of these two columns, maybe income or purchase. Then look for an instance where increase in one column is accompanied by an increase in the other column. So you need to find out whether every time you see an increase or decrease, whether the other column also get increased or decreased. All right? Like always remember the example, years of experience and the salary. As we observe the year of experience increases, salary increases as well. But if you find out that there is no relationship, then no need to have years of experience as inside your resume. Just go apply and you will get high salary, low salary based on your luck, right? But actually there's a link. Everyone knows years experience is quite important in order to get a good salary. So again, sort the values, compare the sorted value in both columns based on which two variables you are trying to identify, if they have patterns or not. Look, for instance, where an increase in one column is accompanied or not by an increase in the other column. Then analyze the relationship between the sorted value to determine whether there's a consistent positive correlation, negative, or no correlation. So we may have positive, negative, or no correlation. So now what we do, let's assume that I would like to focus on income and purchase to see whether there's correlation or not. So we sort them out. This is before sorting. Then after sorting, I take income. So value 60 is the lowest. I put it up. Of course, I need to make sure that the matches for the column, you don't mess around. 60 on income, on purchase amount is 150. Then followed by the following value is 70. 70 with 108. So I'm increasing I'm sorting based on income. Then followed by 75, 200, 85, 250. So just I'm sorting the values on both columns. After sorting, what you notice? So when the income is 60,000, 60K, the purchase amount was 150. When it was 70, then it has become 180. That means there's an increase on X, there's corresponding increase on Y, right? Income and purchase amount, correct? So if your income is low, that means when you go to do purchases, of course, you cannot afford, or we cannot afford to purchase many things. But if our income is high, then we can afford to pay more, right? So this is what we can observe. As the income increases, purchase amount increases as well. Until we reach 95, we see actually the purchase amount has increased significantly, correct? So we can conclude that there is a relationship or correlation between income and purchase. Is it positive or negative? Positive or negative? Positive, right? Because in order to determine whether it's positive or negative, you need to see whether there's same direction happening on both columns. Increase on column 1, also followed by increase on column 2. So they're going in the same direction, like years of experience and salary. As the salary increases, as years of experience increases, salary increases as well. As year of experience decreases, salary decreases as well. So they are going in same direction, either upward or downward. It doesn't matter. But as long as they are going in the same direction, both of them, we say it's positive correlation. Unlike age of the car and the price or the value of the car, they are negatively correlated. Because as the car become older, the price drop down, right? So as again, the age of the car increases, going upward, but the salary or the price of the car going down. So they're going in opposite direction. One going up, the other one going down. So we say negative correlation. So we can conclude that there's a correlation between income and purchase. Also, you can draw a figure, right? So also figure can help us to find out whether there's a correlation or not. So if we draw these two columns, so we find the scatter points and we link them. So we find that there is upward trend. As the value on X increases, the value on Y increases as well. Okay? Clear? Good. So this is the end of proximity measures. Now we can start with data pre-processing. Unless if you have a question,